Okay, this is the video for limits, continuity, differentiability. So there's a lot of notes here. I'm not really going to go through it. Do want to remind you that there were 3 things that had to be true for a function to be continuous at a point. Okay, the point has to exist, the limit has to exist. Usually we have seen these 2 switched in their order, which I don't want that to be confusing. And the third, they have to be the same. Okay, and so then we look at a graph like this, and just as an example, we can see that the limit exists, okay? As x approaches 3 from the left and the right, y equals 0, okay? And there's a point there. But we don't have differentiability, okay? We call that a cusp. All right, and here was another situation where we have continuity but no differentiability, okay? This is a vertical tangent. All right, so on this third page, we have good old definition of the limit using definition of the derivative using the limit. We also have L'Hopital's rule, which is for BC, although we do it because it makes tons of questions easier. Okay, so let's look at problem number 1. You're going to see some of these circled. I'm going to do some of these are going to be x'd out, meaning you don't have to do them. Okay, anytime you have limit as x approaches infinity, these follow the same rules as horizontal asymptotes. Okay, so you look at the degree on top, the degree on bottom, they're the same, so we play that coefficient game. 4 divided by 1, that's 4. If the degree on top had been bigger, then that limit would equal infinity, and we'd answer E. If the degree on bottom had been bigger, that horizontal asymptote would be 0. So just as a hint for 2, you might want to multiply that out before you decide. Okay, number 3. This is a limit definition of derivative. Big indicator here was that we had h. So the first thing is find your f of x. Your f of x is what's after the minus, and sometimes there is no x. So we got to pretend that there's an x right there. So our function is 8x to the 8th. And what this is really telling us to do is to find the derivative, which would be 64x to the 7th. And since there was a number there instead of x, we need to plug that in, so 1/2. Okay, so we have 1/2 to the 7th. Now, this is no calculator here, so we got to figure out, okay, well, what is 1/2 to the 7th? And so really, this is how I would kind of think of it, is we have 7 2's, and just kind of go from there. All right, well, 64, 2 times 2 would be 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So all of those cancels with 64, and you're left with 1/2. That's the answer. Okay, right here, all of this, just to really emphasize this, the limit definition of the derivative is limit as h approaches 0. I skipped over this, but then I'm thinking I need to go over it. This, by definition, is f prime of x. So when you see h, okay, really find the function after the minus, take the derivative. If there's a number, plug the number in. Okay, you get to skip 4, and then the next one we're going to do, you'll do 5 on your own, and then we'll do 6 together. Okay, so this is not limit definition of the derivative. So this is just a plain old limit. So the first thing you would do is just plug 0 in for x. So f of 0 minus f of 0 over 0 squared. This is going to be 0 over 0. This means we use L'Hopital's rule. So just a quick reminder, it means that you're still taking the limit, but we're going to take derivative of the top, which would be f prime of x. F of 0 is a number, so when you take derivative of that, you get 0. So I'm not going to write anything. And then derivative of x squared, that would be 2x. And so then we plug in 0 again. F prime of 0 over 2 times 0. Okay, f prime of 0, we need to come over here and figure it out. All right, what is f prime of x? It is 4x. So f prime of 0, ooh, that's 0. Looks like I'm getting 0 over 0 again, which means I need to use L'Hopital's rule again. This doesn't always happen. I'm kind of picking this one out because it does happen twice. It's a good one to practice. So take the derivative of the top again, take the derivative of the bottom again. At least this time I know I'm not going to get 0 over 0 because I just have a 2 there. Okay, What's f double prime of x? Well, f prime was 4x, so f double prime is 4. It doesn't matter if you plug a 0 in. You just get a 4. There's nothing we can do there except simplify to 2. So that's our answer. Okay, that's how you use L'Hopital's rule, and you only use it when you get 0 over 0, or you could use it if you have infinity over infinity. Okay, so all of these that I'm skipping, you are going to do. So the next one we are going to do together is number 13. Okay, no calculator again. Which of the following are true? So first, let's consider, does the limit exist? Okay, this means I need to be able to plug in 3 to the top, and I need to be able to plug in 3 to the bottom, and I better get the same. Okay, 3 plus 2, that's 5. That's the left-sided limit. The right-sided limit, 12 minus 7, that's also 5. So the limit does exist, okay? So 1 is true. So I'm going to go ahead and cross off the ones I know are not true. Okay, so is f continuous? So remember with continuity, you needed the limit, check. You needed a point. Now because there's a little or equal to here, we already know that f of 5, or sorry, not f of 5, f of 3 is 5. Okay, because of the or equal to, that told us that. So we have the point and they're the same. So I have everything I need. So big check next to continuous. So 1 and 2 are true, so it can't be B. Now we just got to figure out, is 3 true? Well, that means we got to find the derivative. Okay, derivative of the top piece would be 1. Keep this little piece the same. Derivative of the bottom would be 4. Keep this x greater than 3. And now I don't even have an x to plug 3 into, but I know that 1 is not equal to 4. So 3 is not true, which means that my answer is D. Okay, you are going to do all the rest. I'm kind of just double checking. I am assigning a lot of these problems, but mostly because they don't take that long. All right, now in 24, this is a free response. We're gonna do this one together. Is f continuous? Explain where we're not. We gotta be careful about how we write this. So I need to figure out what is the left-sided limit. What is the limit as x approaches 3 from the left? All right, so where is x less than 3? It's in this square root piece. Okay, so that's square root of 3 plus 1, or square root of 4, which would be 2. Okay, now let's find the limit as x approaches 3 from the right. This would be plugging into the 5 minus x piece, so 5 minus 3, that's also 2. So what this tells us is that the limit as x approaches 3 of f of x equals 2. Okay, remember when we used to do like 1, 2, 3, all of that is 1. Okay, here's step 2. What's f of 3? Well, it was from this or equal to part. We already know what happens. We plug it in, we get 3 plus 1, square root of 4 is 2. Okay, great. And then 3, f of 2, and limit, I don't know why I wrote 2 there, f of 3, and limit as x approaches 3 of f of x, they're the same. They both equal 2. Therefore, f of x is continuous at x equals 3. Okay. I'd give you more room if you needed to do this later on. Okay, so part B was skipped because that was something we don't know how to do yet, and so now we're going to look at C. We have this function, it's a piecewise, of course. K and M are constants, and we need to find out what is K and M if G is differentiable. Okay, so we need to find G prime of X. All right, now we know if we're going to take derivative, we got to do that. Now K is a number, so I don't have to do product rule here. I can just treat this as any other number. 1/2 K. We'll leave the X plus 1 alone. We'll subtract by 1. And we could do like a little times 1 for good measure there. All right, so that's I really should be putting that. That's the top piece. That's for 0 less than or equal to x less than or equal to 3. Now for the bottom piece, this would be like 5x plus 2 or 7x plus 2. So the derivative would just be m. Okay? Derivative of 2 is 0. Derivative of mx is just m. So if I want differentiability, what I need is for these two things to equal each other when x equals 3. So I have my 1/2 k. And this is like 1 over square root of x plus 1. Okay, and I'm going to even rewrite this better than this. I'm going to do k over 2 square root of x plus 1 equals m. Now remember, x is supposed to be 3. Okay, so let's just go ahead and plug this in here. 3. So that's going to be k over, 3 plus 1 is 4, square root of 4 is 2, and 2 times 2 is 4. All right, so now we know that k equals 4m, and that's all great, except I still don't know what k or m equals exactly. Okay, so we also have the continuity piece, meaning just these two things are equal to each other. In other words, k square root of x plus 1, that equals mx plus 2. So aren't you glad I'm doing this one with you instead of by yourself? So let's plug in 3. So I'm going to write this as 3m. It's just m times 3. All right, so again, 3 plus 1 is 4. Square root of 4 is 2, so that's going to be 2k equals 3m plus 2. And now I have a system. So I'm going to go ahead and take this 4m. I'm going to plug it in for k here. So 2 times 4m equals 3m plus 2. So that's 8m minus the 3m makes 5m. So now I know that m equals 2/5. Okay, so what does then k equal? K equals 4 times that, which would be 8/5. So messy and gross, I know, but it is what it is. Okay, good news is you do not have to do 25 at all. Okay, it's the next free response. If you go, or 26, if you go on the next page, it does show how to grade that one and some student responses. These are not all correct. We're going to look at some of that stuff, but you really don't need to do that. So when you're working this problem, you're just going to go through 23, except X out the ones I already told you to X out. Okay.